In this video, we're going to continue to talk about vectors, and specifically, we are going to talk about how to put geometric vectors in a coordinate system. We will use the example of the Euclidean 2 space in this video, and eventually in later videos we'll start talking about Euclidean 3 space and others. In the previous video, we talked about the definition of equivalent vectors. This definition makes sense because two vectors with the same magnitude and direction should be considered the same, and it's also very useful because now if we want to compare two vectors that have different initial and terminal points, let's say vector AB and vector CD, then we can just move one of them around. So let's say we move AB to A prime, B prime, so that A prime coincides with point C, so that vector AB and vector A prime, B prime are equivalent. Then we can compare A prime, B prime and vector CD in a convenient way. For the same reason, if we're comparing multiple vectors, we can all force them to have the same initial point. Let's say the initial point is called point O. Then vector OA, vector OB, vector OC, and vector OD all have the same initial points. This gives us the inspiration that we can put all these vectors in a coordinate system where the point O is the origin, so that we can describe these vectors with algebraic methods. So suppose we have all these vectors in an xOy coordinate system, then what distinguishes these vectors are just their terminal points, because their initial points are all at the origin, point O. Suppose the coordinates of point A are the two tuple a sub 1, a sub 2, where a sub 1 is the x-coordinate and a sub 2 is the y-coordinate, then we can essentially represent vector OA with this two tuple a sub 1, a sub 2. Similarly, if the coordinates of point B are b sub 1, b sub 2, then we can represent the vector OB with the two tuple b sub 1, b sub 2. So we see that every point in the xOy coordinate system corresponds to a vector, and every vector in the xOy plane corresponds to a point in the xOy coordinate system once we move the vector to an equivalent vector whose initial point is at the origin. Let's say the equivalent vector is named vector V, and the endpoint is capital V. So vector V would be equal to vector OV, and its algebraic representation would be the two tuple v sub 1, v sub 2, which are the coordinates of point V. I'd like to take a moment here and emphasize a few concepts. The xOy plane is often referred to as the Euclidean 2 space with the notation R2. The Euclidean 2 space, R2, is algebraically defined as the set of all two tuples where each coordinate of the two tuples are real numbers. Now, because every two tuple corresponds to a point in the xOy plane, R2 is also the set of all points in the xOy plane, which is the xOy plane itself. In the meantime, because every two tuple also represents a vector in the xOy plane, R2 is also the set of all vectors in the xOy plane. The take-home message here is that the different meanings, the seemingly different meanings of R2 are because of the one-to-one correspondence of two tuples, points in the xOy plane, and vectors in the xOy plane. It is very important that we understand this one-to-one correspondence and the meaning of the Euclidean 2 space before we move on to more complicated concepts.